Good morning, girls. How are you? I hope you are all doing fine. Okay, today in our video, we will be doing some extra questions about lesson 19.4, and then we are doing lesson 19.5, which is a very small lesson and easy lesson. Okay, if you remember, what did we do yesterday? We took some theorems involving perpendicular lines. And we said perpendicular lines mean that you have two lines that intersect in one point and that the angle between them is 90 degree. Like in here, for example, these two lines intersect together and the angle between them is 90 degree. And the first theorem that we took yesterday was the perpendicular bisector theorem. And we said, what does it mean to be perpendicular bisector? Perpendicular bisector, we said that when you have two lines and the line bisect your segment into exactly two equal halves and that this angle is 90. Then what will happen? You remember? These two parts will be exactly equal. These two distances will be exactly equal. Yani PA will be exactly equal to PB. And then we went and took the converse of this theorem. How did we get the converse of this theorem? The converse say the opposite, that if these two parts were equal, so actually BC will be equal to AB and this angle will be 90 degree. Yani if these two parts were equal, so BD will be perpendicular bisector of AC. And then we took some theorems about right angles. What was the theorems of a right angle? We said again, if you have two lines intersecting together, they will form four angles, right? If one of them is 90 degree, so actually the other three will be 90. This will be 90, this will be 90, this will be 90, and this will be 90. All of them will be 90 degree. And then the last thing we took was, what about if again we have two lines, they are intersecting together, they are forming this time only two angles, 1 and 2. If these two angles were said to be exactly equal, he didn't tell you that measure angle 1 is 90 this time, but he told you that they are exactly equal. 1 is equal to 2. If 1 is equal to 2 and you are sure that they are making a linear pair, so actually each one of them will be 90 degree, right? Okay, and I left for you some homework to do. You are still have time for today to try to finish it. I'm not going to do it with you. And we have some extra questions to do together. Beginning by in page 971. In page 971, I have to do question 8. Okay, question 8 is related to this figure. As you can see in this figure, we have two triangles, APC and BQD. And what's required? Use the diagram to find the length. BP, this thing here, is the perpendicular bisector of AC. It means that AB is exactly equal to BC and that this angle is 90. So using the perpendicular theorem, I know that PA should be equal to PC. Very good. And CQ is the perpendicular bisector of BD. Is the perpendicular bisector of BD. So again, I understand it means that BC will be equal to CD and that this angle will be 90. And using the perpendicular bisector theorem, I know that QB should be equal to QD. And even he is helping you here, he is telling you, so AB will be equal to BC equal to CD. Let's solve question 8. Suppose that BP is 3 centimeter and AD is 12 centimeter. What is the length of PC? Again, suppose that PB, this line in here, this standing line in here is 3 centimeters. So I know this line in here. This is exactly 3. And AD is from here till here, girls. It's 12 centimeter. First of all, AD is 12 centimeter, right? This 12 centimeter is divided into exactly 3 equal parts, right or not? Because he is telling you that this is equal to this is equal to this. So actually, To know AB and BC and CD, I can just divide 12 by 3. Right? We can divide 12 by 3. So this is the first part. In here, to find each part of this, I'm going just to divide 12 by 3. So A, B will be equal to B, C will be equal to C, D will be equal to 12 divided by 3, which is a 4. So I know now that this is 4, and this is 4, and this is 4. And we can even just like write in here. So this is 4, this is 4, and this is 4. And BP is 3. This line in here is 3. What is the question? What is the length of BC? Can you see this triangle in here? Can we extract it here just to see it? I'm going to extract it here. So I have a triangle in here, in which this is exactly 90 degrees. This is 3, and this is 4. How can I find this using the what? Whenever you have a right angle triangle, you have to think about which theorem? The Pythagorean theorem right away. To find the Pythagorean theorem, what should I do? You remember the Pythagorean theorem? This will always be C, this will always be A, and this will always be B, and then you have to use the rule C square will be equal to A square plus B square, and then you will find C. Let's find it. So let's find it in here. So C square will be equal to 3 square. 3 square is what? Right away. 3 square is 9. Plus B square, which is a 4 square. 4 square is a what? Is a 16. Very good. C square, 9 plus 16 will be a 25. So C square will be equal to 25. And then the question, am I finding C square, or I only want to find C? I only want to find what? I only want to find C, right? So how can I get rid of the square? I have to do what? What is the inverse of the square? You know, the inverse of addition is subtraction. Inverse of multiplication is division. What is the inverse of squaring? Square root. Very good. So this is what I'm going to do. So C is going to be just, you are going to add a square root of 25. So square root of 25 will be a 5. So C is equal to 5 centimeters. Or not C in here, but here it is a PC, which is the question. So PC is equal to 25. PC is, is equal to 5. PC is equal to 5. Okay? Okay, so this is question 8. This is question 8. Okay. And then we have to do question 12. Okay, let's go to question 12 in here. Given that M is parallel to N and X is parallel to Y, you know that this sign is parallel, and Y is perpendicular on M. Let's see, where is Y? Y is perpendicular on M. Y is perpendicular on M. It means what? It means that this angle is 90. Since one angle is 90, so all of the other 4 angles are 90. So 7, 8 together are 90. This angle is 90, and this part here is 90. And since Y and X are parallel together, so actually even X and M are perpendicular. So this is 90, 90, 90, and 90. Going here, 90, 90, 90, 90, and 90, 90, 90, 90. So anyway, question 12. Suppose that measure angle 7 is 30 degrees. Find measure angle 3. Some of you yesterday, we had a question similar to this, I think in question 7, I think. And you just wrote the answer that measure whatever is equal to whatever degree. This is not acceptable, of course. You have to tell me, how did you find it? We took some theorems, girl. We took that there is the alternate interior theorem. There is the alternate exterior. There is the corresponding angle theorem. There is the same side interior postulate. You have to tell me each step of the way, and we're not just like giving me the answer from where did you find the answer. I need to understand that you already understood. Anyway, so how from measure angle 7 I can find measure angle 3? By the way, there is a lot of ways to solve this. I told you geometry can be solved in many ways. Okay, I will tell you one way, for example. Measure angle 7 is equal to 30. M is parallel to N, right? M is parallel to N, right? Very well. M is parallel to N. So, and he told you that Y is perpendicular to M. Since Y is perpendicular to M, so 7 and 8 together are what we said? 7 and 8 together are 90 degrees, right? 7 and 8 together are 90 degrees. For now, I know that measure angle 7 plus angle 8 is 90. How can I find measure angle 8 alone? So measure angle 8 alone will be 90 minus 30, which is a 60 degree. So we have known that measure angle 8 is 90 degree, sorry, 60 degree. Is it enough for us? Okay, M and N are parallel to each other, right? Can't you see this Z? Can't you see this Z? Try to see it with me. This Z in here. There is a Z in here, but it's a flipped Z. This is a Z, right? Yes, we found the Z. Using this Z, we can say that, or actually it is better to do it in the other Z. See this Z with me in here. It's not flipped or anything. It's very, very obvious Z. Can you see this Z? Yes, this is a Z. Using the alternate interior theorem involving the Z, measure angle 8 will be equal to measure angle what? Exactly measure angle 6, right? Because this is the alternate interior angle theorem. So this is what we are going to be writing in here. So in here, measure angle 6 is equal to measure angle 8 equal to 60 degree using what? Using the alternate interior angle theorem. Very good. So still, for now, I know that 8 is equal to 6. So I know that 6 is 60 degree. And then, what is the relation between 6 and 3? What is the relation between 6 and 3? They are what? Can't you see this X in here? We have an X in here, right? We have an X in here, girls. If you try to see it. Let's see the X in here. There is an X in here. Yes, and yes. Yes, did you see this X? So angle 6 is exactly in front of angle 3. Angle 6 is exactly in front of angle 3. So this is a relation of what? This is a relation of alternate interior angle theorem. Alternate interior angle, vertically opposite angle, sorry. This is the relation of vertically opposite angle, right? So we can write in here that measure angle 3 will be equal to angle 6 equal to 60 degree using what? Vertical angle theorem. And that's it. You found your angle. So I found my angle by, first of all, I used the definition of perpendicular to find measure angle 8. And then using Z, I found the alternate interior angle theorem. And then using the vertically angle theorem, I found angle 3. Understood? Okay. Okay. We still have to do question 14. Let's go down and see question 14. Okay. Use this diagram of trusses for a railroad bridge in exercise 15. Suppose that BE, where is BE? This is BE, is the perpendicular bisector of DF up here. What does it mean? It's the perpendicular bisector of DF. It means that angle 3 and 4 is 90, and that exactly DE is equal to EF, right? And it means, using the perpendicular bisector theorem, that DB will be equal to BF. Didn't we say this? That the point on the line will be equidistant from the end points of your segment, right? So DB, sorry, will be exactly equal to BF. Now, let's read the question. Which of the following statements do you know are true? Select all that apply and explain your reasoning. Let's see which of them is true and which of them is false. First of all, BD, he is saying that BD is equal to BF. Of course, this is true using the perpendicular bisector theorem. This is true using the perpendicular bisector theorem. So here I'm going to tell him it's true by perpendicular bisector theorem. Okay, very well. Let's see question B. Question B, measure angle 1 plus 2 is 90. Let's see it. He is saying that measure angle 1 plus 2 is 90 degrees. What do you think? What do you think? I will tell you. I know for sure, since he told me that this is the perpendicular bisector of DF, that angle 3 and 4 together is 90. This is something I know for sure. 3 and 4 are 90 degrees. But do I know by sure that 1 and 2 are equal to 90 degrees? What do you think? Okay. Actually, I know for sure that 3 and 4 are 90 degrees. But do you know for sure that 1 and 2 is equal to 90 degrees? You know when you were going to be sure? If he told me that DF is parallel to AC. If DF was parallel to AC, then these two angles will be alternate interior. So they will be equal. But even the information of parallelism, he didn't tell it to me. So am I sure that angle 1 and 2 are exactly 90 degrees? Actually, the information is not enough. The information actually is not enough. So he didn't tell you to write true or false. Just write true beside the true. So 1 and 2, I'm not sure of the information. The information is not enough. So I can't say for sure that it's true. So I'm going to leave it empty. Question C. E is the midpoint of DF. Of course, it is the midpoint because this is the definition of bisector. Since BE is the bisector of DF, so E is the midpoint of DF. So of course, this here is true. Definition of bisector, right? Very well. Question D, measure angle 3 plus 4 equal to 90 degrees. Again, true, because this is the definition of perpendicular. Because he told you that BE is the perpendicular bisector of DF. So angle 3 and 4, I am sure it's 90. So of course, again, this is true. Why? Definition of perpendicular. Then what about DA? DA is parallel to, is perpendicular to AC. DA is perpendicular to AC. What do you think? Did he give you any information to suggest that DA is parallel to AC? Is the information here enough? No, it's not enough for me to make sure that they are perpendicular. So DA, the information here is not enough for me to say that this is true. So the only true I have is A, C, and D. Okay. We still have question what? We finished question 14. We still have question 19. Let's see it. Is it important to do or no? Question 19 is in here. Analyze the relationship. Complete the indirect proof. No, we already did it before, the indirect proof, and we understood it. As that's it, it's enough for us. So lesson 19.4 is done. We are beginning now in lesson 19.5. Okay, lesson 19.5 is like a break for you from geometry a little bit. Beginning from module 16, we have been dealing heavily with geometry. Module 16, 17, 18, and now 19. Lesson 19.5 are talking about equations of parallel and perpendicular lines. Actually, it doesn't involve any geometry. Most of the time, there is no geometry in here. Most of the time, we will be dealing with equations. You remember the equation of linear line? You remember the equation of linear line, which is like the slope-intercept form, y equal to mx plus b. This is what we are going to be dealing with in here. Why did it come in module 19? Because you are going to be talking about parallel lines and perpendicular lines. Yani it's not just an equation of a line. Already we took it many times. No, it's a special equation for parallel lines and perpendicular lines. Okay, but it's very easy lesson, really very easy lesson. You will find it, and I want to tell you, it's not just easy. It's very, 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 very important lesson. The equations of parallel and perpendicular lines are used heavily in SAT exams. So this lesson actually is easy. It's a break from geometry and it's very important. Okay, let's beginning by, we are girls in page 975. Okay, how can you find the equation of a line that is parallel or perpendicular to a given line? Yeah, and what will happen today, what is different from the previous modules when we talked about lines, is that this time you will be having two lines together on the same graph. Either they are parallel or they are perpendicular. And one of them have a known slope. And you are required to use your information about parallel and perpendicular lines to find the slope and the y-intercept of the second line. This is the lesson of today. Okay, first of all, exploring slopes of lines. Recall that the slope, you remember the slope, girls, we said that the slope have two rules, you remember? M was either equal to y2 minus y1 over x2 minus x1. You remember this was the first rule. If you are using points, you can use this rule, y2 minus y1 over x2 minus x1. Or there was another rule for m, which is, of course, m should be like small letter. So the other rule was rise over run. You remember? Rise over run. And you can use whatever you want. If you have a line, you can just get 2 points and then use the formula or use the rise over run. Here he is recalling for us what was the rise and run. For example, let's say I have 2 points. Point A here is -4 and -3. Point B is 4 and 1. The rise is this part. You remember we said rise, you are going up or down, so it's a y-axis. Run is the x-axis. Since it is a rise over run, you are going to count how many squares. So the rise is from A to B. We rose how many points? 1, 2, 3, and 4. So the rise is equal to 4. What about the run? The run, I moved from A to B. Let's count. 1, 2, 1, 2, 3, 4, 5, 6, 7, and 8. So the run is equal to 8. Since I found my rise and I found my run, now I can do what? Rise over run. So the rise over run is 4 over 8, which is a half. 1 over 2. If you use the formula using these 2 points, as if you are going to say that this is x here, for example, x1, y1, x2, y2, and then you are going to put this inside the formula, you will find that the slope is again 1/2. And both of them will give you the same answer. But I prefer the formula method actually. It's more accurate because sometimes the square is involving 2 points and you may be confused. So it's easier to use the formula method. Anyway, here he is telling you to graph the equations y equal to 2x plus 1 and y equal to 2x minus 3. I have to graph the equations. How can I graph the equations? He is giving you 2 equations and we need to graph them. How can I graph 2 equations? What should I do to graph an equation? I should do what? This is an equation of lines. So for a line, how many points do I need to graph a line? I need 2 points. So this is what we are going to do. We are going to make a table as usual. Let's do a table. I'm going to do a table for x and y for the first line. And then we are going to do another table for x and y for the second line. And then let's choose any values for x. So try to choose values we already have. So let's choose 0 and 2, for example. Let's choose 0 and 2. So 0 and 2, for example. And let's do the same thing in here, 0 and 2. Okay, let's begin in here by putting 0 in here. So 0 plus 1 is a 1. 1 multiplied 2 is a 2. So 0 and 2 is my first point. Then let's put 1. 1 plus 1 is a 2. 2 multiplied 2 is a 4. So 1 and 4. Right? What about here? Using the second line. Let's substitute. 2 multiplied 0 is a 0. 0 minus 3 is minus 3. So 0 and negative 3 is the first point. And then 2. 2 multiplied 2 is a 4. 4 minus 3 is a 1. So 2 and 1. And then let's put the points. 0 and 2. 0 and 2 will be up here. 1 and 4. 1 and 4 will be in here. And then what should I do with this? I should draw the line. If I draw the line for you, it's going to be very, very, yeah, maybe I can use this. Like it's going to be like this. And then let's 0 and negative 3. Where is the 0 and negative 3? Down in here. And then 2 and 1. Where is 2 and 1? 2 and 1 is here. And then what should I do with these points? I should connect them. No. So these are my 2 lines. These are my 2 lines. Very well. Question B. What do you notice about the graphs of the 2 lines? What do you think, girls? What do you think about these 2 lines? By the way, you can even use the graphing calculator for you to make sure of your answers. You know, we can even use the graphing calculator. But since it's a very, very easy equation, I didn't use it. I just grabbed it right away. It's very easy. So what do you notice about the 2 lines? They are what? They are parallel, right? It's very obvious that actually they are parallel. So here we can write that they are parallel. So the equation, the lines or the graphs of the 2 lines are parallel. The 2 lines are parallel, right? What about the slopes of the line? If you try to find the slope from here, girls, if you try to find the slopes from here, what is the slope in here? What is the slope in here? You remember y equal to mx plus b, right? What is m in here? M is 2. So here m is 2. This is m, right? What about in here? Where is m? Again, you can open the bracket. So y is going to be equal to 2x plus 2. And then the slope is going to be 2. This is like the point slope form, y minus y1 equal mx minus x1. But in here, y1 was 0, for example. Anyway, m here is 2 and m here is 2. So we discovered that they were parallel lines, right? And m was, yani m1 equal to, and m2 is equal to 2, which means that they have the same slope, right? So from here, we can say a very, very, very important note. Whenever you have parallel lines, the slopes are always equal. Yani in other words, when he gives you 2 lines and you are required to write the equation, for example, you don't know anything about the first equation. You don't know, for example, anything about the first equation. But he is telling you that the second line is parallel to the first line. Whenever you hear this word parallel lines, so their slopes are equal. So the slopes are equal. Very, very, very important. Okay, let's see what about question C. Let's go to question C. For now, I understood. For parallel lines, they have same slope. Okay, use the graphs of x plus 3y equal to 22 and y equal to 3x minus 14 are shown. Already the graphs are drawn this time. Use a protractor. What is the measures of the angles formed by the intersection of the lines? What does he want in here? He wants you to use your protractor. Try to use your protractor. My protractor are not going to be opened here. But how can I use the protractor, girls? He wants you to measure the angle in here. So just you are going to get your protractor and then you will put the center on the center, and then put the line on the line and please measure this. What will be the angle formed? The angle will be exactly 90 degrees, which means that these 2 lines are perpendicular. So what is the measure of the angle formed by the intersection of the lines? The angle should be 90 degrees. The angle should be exactly 90 degrees. So here I'm going to tell him it's a 90-degree angle. What does it tell you about the lines? That the lines are perpendicular. The lines are perpendicular. Right? Okay. And then, what are the slopes of the 2 lines? How are they related? Let's find the slope of this line and find the slope of this line. But from here, it's very easy. Again, y equal to mx plus b, so m is 3. For here, it's very easy. M is 3. So what about here? This is the standard form. The standard form is not enough for me to find the slope. So I have to work my way through this equation. I have to turn it into this form. So let's do it together. This is nothing new, by the way. All of this, we already took it before. So x plus 3y is equal to 22. To turn it into this way, I want y to be alone, right? So I have to change x to the other side. So x will be in here. So 3y will be 22 minus x, right? Just to make it in this form, I will put, anyway, to make it into this form, I will put x first. So 3y is going to be negative x. I just swapped places, plus 22. I swapped the x, I put it in the first, and then 22 in here. Am I done? No, because y is not alone. I have to remove 3. How can I remove 3? Divide by 3. Let's divide by 3. So y equal Here I will divide by 3. When you are dividing by 3, girls, I have to divide by 3 here and here. So here is going to be negative 1 over 3x plus 22 over 3. Right? Is it in the slope-intercept form? Yes, it is. It is in the slope-intercept form now. What is the value of the slope? This is the value of the slope. This is my slope, right? The thing beside x. So this is the slope. And we can write in here that the slope of the first line, m1, is equal to negative 1 over 3, and m2 is equal to 3. Let's think about them. How are they related? Are they equal? Of course they are not equal. Of course they are not equal. How are they related? How are they related? You know, this is 3 and this is 3. Yani as if you did what? As if you multiplied m2 by negative and then you put the denominator down. Yani here it was a denominator. Here it was a numerator. You multiplied it by negative and then you put it in the denominator. Right? Very good. So it means what? It means that the relation will be, it means as if that they are reciprocals of each other, but they are opposite sign. They are opposite sign. So this is what we are going to be writing in here. So they are opposite reciprocals. They are opposite reciprocals. You remember the reciprocal? Reciprocal is like when you reciprocal is like A over B will be B over A. So this is what happened. 3, my 3 means 3 over 1, girls, right? The reciprocal of 3 over 1 is 1 over 3. Why did I put the word opposite? Because there is a negative sign. So it is like the opposite reciprocals of each other. So complete the statement. If two non-vertical lines are parallel, so they will have equal slopes. If two non-vertical lines are perpendicular, then the product of their slope is the product of their slopes. What is this? I will try with you a very, very small experiment. M1 here was negative 1 over 3, right? M1 was negative 1 over 3. Negative 1 over 3. What if we multiplied it by 3? Yani I did M1 multiply M2. Let's go and find negative 1 over 3 multiply 3 is negative 1. So actually, this is what we are going to be writing in here. This is what we are going to be writing in here. Whenever you have, sorry, this was not equal. Whenever you have parallel lines, their slopes will be equal. Whenever you have perpendicular lines, the slopes are not equal. The slopes are opposite reciprocal. But the word opposite reciprocal is a little bit hard. I can't work with it. Yani, are they equal or not? No, they are not equal. But their product will be negative 1. The product will always be negative 1. So we can always write in here a note which summarizes the whole lesson. Your whole lesson will be in this part. Equal parallel lines means that M1 will be equal to M2. Perpendicular lines means that if I get M1 and multiplied it by M2, the answer will always be negative 1. It comes heavily, girls, in the set exams. He will give you the slope of a line and then he will tell you that the two lines were perpendicular, find the slope of the second line. Always remember, when they are parallel, so they have the same slope. When they are perpendicular, so they are not the same, but if I multiplied the two slopes together, the answer will be negative 1. So this is the lesson, okay? How can I utilize this? We will see now. Let's go back to our book and see. Okay, let's go to the second page. In here, explain 1. Writing equations of parallel lines. You know that I love not to work inside the boxes, right? So I will solve with you question A and I will tell you how to do it exactly. And then you will do B and your turn together by yourself. Let's read the question. Write the equation of each line in slope-intercept form. You remember what was the slope-intercept form, right? Of course you remember. You're supposed to remember. Y equal to mx plus b. This is what you want. And the given is the line is parallel to y equal to 5x plus 1. And that line passes through -1 and 2. Remember, girls, to write a line in slope-intercept form, it means that I need to find what and what. I need to find m and b, right? Okay. But before, to find m, he gave us, for example, 2 points to find the slope from. y2 minus y1, right? Remember now, there is no graph, there is no 2 points, it's only 1 point, as you can see. But he gave you another information, that the line you are trying to put the equation for is parallel to this line. We just said, when I have 2 lines parallel, their slopes are equal. Their slopes are equal, right? What is the slope of this line? Where is the slope of this line? This is the slope of the line, right? So this is M1. So M1 will be M2 because they are parallel. So I found my slope. So in here, M1 will be equal to M2 equal to 5. We found our slope. Very well. I still have B. How can I find B? By substituting to find B. Let's substitute. Let's put Y instead of Y. Of course, this is X and this is Y. So 2 is going to be 5 multiply X, which is a -1. I'm using the point, plus B. And then 5 multiply -1 is -5. So 2 equal -5 plus B. And then how can I find B? Let's shift for -5 to the other side. -5 will be shifted with a +5. So B will be a 7. I found B. What should I do now? I can write my equation. Y equal M, which is 5. So 5x plus B, which is a 7. You finished your question. Actually, it's nothing new. But just before, he used to give me 2 points. And from the 2 points, I will use the formula y2 minus y1 over x2 minus x1 to find the slope, right? This was before. This time, it is just a very, very slight difference. Instead of giving you 2 points, he is giving you another line which is parallel or perpendicular. For parallel, as we said, it's very, very easy. I just copied the slope of the line and put it for my line. And then to find B, as we did before, substituting the point to find the B, and then I will put the line. Very easy, right? Very, very easy. Please, girls, write this. Here he is using the point slope form. I always find that the slope intercept form is much, much easier. But if this is easier for you, you can do it. Anyway, but at the end, reach the slope intercept form. Okay? So this is my solution. You can write it here beside the question, and then you are required to do question B by yourself. You are required to do question B by yourself. Okay? The same idea. Very easy. The same idea. So B is going to be done by you, and even number 4 and number 5. Because actually it's very easy. I don't need to do it for you. It's very, very easy. I will give you the model answers, inshallah, maybe tomorrow, but this is very, very easy. You can do it by yourself. So B, 4 and 5. And then the last thing for today, writing equations of perpendicular lines. Let's utilize the perpendicular line and see how can I solve it. Okay, let's read the question. Write the equation of each line in slope-intercept form. Again, y equal to mx plus b. The line is perpendicular to, this time it's perpendicular, not equal, not parallel, it's perpendicular. Whenever I see the word perpendicular, I will write for myself the note that I wrote. Perpendicular means m1 multiply m2 should be -1, right? What is the value of m1 here? What is the value of m1? m1 is 4, is what here? It's 4, right? This is the place of m. So it means that 4 multiply. Do I know the slope of the second line? No, I don't. I need to find it. Now, this is the question. You are trying to find the m so that you can write the equation. If I don't know it, so it's again an m2. And this is equal to -1. Very well. How can I find m2? What should I do? I should remove 4 from here, right? How can I remove 4? This is 4m2 equal to -1. Girls, the thing I'm doing here, it's a multiplication. This is multiplication. Yani it's like a dot. Yani if the multiplication is confusing you, we can put a dot. This is easier, maybe? Yes, this is easier. So it's a dot. 4m2 is equal to -1. 4m2 is equal to -1. How can I remove the 4? I will divide by 4 to the both sides. So m2 is going to be, if you divide -1 by 4, it's going to be like -0.25. I found m2. So did you understand how did we find it? They are not equal this time. You are just going to do a very, very, very small division problem, and then you will find your m. I found my m. And then what should I do? Again, like the previous example, I'm going to use this point and substitute it in here to find b. So let's do it. So, of course, this is x, this is y. So -1 equal to -0.5, which is the slope I just got, m, multiply x. What is the value of x? It's a 3. And then plus b. Okay. -0.25 multiply 3. Let's find the answer. -0.25 multiply 3. It's -0.75. So here, -1 became equal to -0.75 plus b. How can I find b? I will shift -0.75 to the other side. Shift it with a positive sign, because here it's a negative, it will be shifted positive. So -1 plus 0.75 equal to b. So b will be -0.25. So b will be -0.25. I found b. And I have my m. Now I can write my equation. So y is equal to m was -0.25 x minus, because b is minus, 0.25. And you are done. This is your equation. Of course, -0.25 is the same as -1/4. Do not tell me, teacher, you did something wrong. No, it is the same. -1/4 is the same as -0.25. Again, here he is using the point slope form. I find it very much easier for me to use the slope intercept form. If you are familiar with this more, you can use it. It will give you the same answer at the end. Okay. Again, you are going to be, inshallah, doing number B in here. You can use outside the boxes, use your own work in here. And after doing this, do question 7 and question 8 as well, and send me your answers, please. And we are done for today. Thank you very, very much. Please go to the Class Dojo post to see exactly what to do. And thank you.